Good morning, everyone. So I hope my screen is visible to everyone and I'm also audible. Can anyone confirm here?
Yes, sir.
Okay, fine. So we will begin with paper discussion. Uh, let's see what is question number one today. So question number one, there is a thin wire and it is bent into form of a square loop and a battery of 2 volt is connected between the points. The magnetic induction due to the current in the loop at the center O will be. Well, this is quite easy because here the current will be I by 2, and here also it's going to be I by 2 and I by 2. Now at the center, what will be the magnetic induction? Because of I by 2 and I by 2, A to D and D to C, the magnetic field will be into the plane, and because of the current in the wire AB to BC, magnetic field will be out of the plane, and therefore since the magnetic field are also equal in magnitude, the net magnetic field is going to be zero. So first option will be correct. Let's see question number 2. The magnetic induction due to circular current carrying conductor. Oh, by the way, better that whatever doubts that you have, we will take it. So from 1 to 8, you can see it on the screen. If you have any doubt in 1 to 8, please ask me, or you can also write it on the chat
Five.
box. Question number 5. Question number 5. Okay. So question number 5. Apart from question number 5, is there any other question that you want me to discuss?
Seven. Seven.
Question
Seven.
number 4, answer is 2. Okay. Question number 7. Fine. On this page itself, up to 8, question number 5 and 7, we will take
Eight
for
also.
discussion. 8 is
Eight,
also
sir.
there. Okay. So question number 8, answer is not visible. Answer is option number 1. Okay, fine. So let's take question
Four.
number 5, 7 and 8. Um, meanwhile,
Fourth one.
what happened?
Fourth one also.
Fourth one also. Okay. So question number 4 is also there. Fine. Let's see. So question number 4, we will start first. Question number 4 says, when a charged particle moves at right angle to a magnetic field, then which of the following quantities changes? Energy, it doesn't change. Speed doesn't change. Momentum, why? Because the direction will change. It will move in a uniform circular motion, and therefore momentum will change for sure. I hope it is clear.
अच्छा
Next.
डायरेक्शन में चेंज होता है ना.
Direct, because it's a circular motion, right?
सर वही मैं समझ ही नहीं आता, कोई ऑप्शन ही सही नहीं लग रहा था, डायरेक्शन ये मैं भूल ही गया.
Direction, so we have to take care. Next question number 5. A proton, an alpha particle, enters a uniform magnetic field at right angles to it with same velocity. The time period of alpha particle as compared to that of proton will be. So in question number 5, we have to compare the time period. Let us see the formula for time period. Time period is equal to 2 pi m upon q into b. Now, if you look at and compare the masses of alpha particle and proton, for proton, if the mass is m, then what is the mass for alpha particle? It is 4 times m. And the charge for proton, it is E, then the charge for alpha particle is 2 times E. So what matters here is the ratio of m to q. So we will compare the ratio of m to q. Then for alpha particle, what will be the ratio for m to q? For alpha particle, the ratio will come out to be which where the ratio will be more. Basically, this is going to be 2 times m by e, and the ratio for proton, it is m by e. Now I think we can compare the time period for the alpha particle and for the proton. So the time period of alpha particle as compared, because the ratio of m by e is double in case of alpha particle, therefore the time period will be double, and therefore in option
Sir, your voice is not audible.
is it not audible to everyone? Hello, just a second.
सर आपकी आवाज नहीं आ रही है.
Am I audible now, by the way?
Yes sir.
Yes.
Okay, so just hang on. I have to. Uh, and the screen is also visible, right?
No sir. Now it's visible.
Now it's visible. Okay, fine then. So we will continue what we were discussing. We were discussing about the ratio of time period for the alpha particle and proton. I hope it is clear, since the ratio of mass to charge is twice in case of alpha particle, so the time period will also be twice. Let's now move on to the next question, number 7. What it says, question number 7 is consider a long straight wire of cross section area A carrying a current I. Let there be n free electrons per unit volume. An observer places himself on a trolley moving in the direction opposite to the direction of current with a speed of I upon NAE. That means he is moving with drift velocity. Separated from the wire by a distance r, the magnetic field seen by this observer is. So we have already discussed this problem, question number 7, when we discussed the frame dependency of the magnetic electromagnetic field. So when there is an observer here and this observer is moving in the downward direction with velocity Vd, for this observer the electrons will be at rest. However, the protons and the bound electrons will be moving, and the magnetic field is also going to be same for this observer as well, and the same magnetic field formula we can use, mu naught upon 2 pi I by r. So I hope there is no doubt, because we already discussed it in the class, that there will be magnetic field for this observer as well. Now next, question number 8. An electron moving along the x-axis with an initial energy of 100 electron volt, it enters a region of magnetic field B as seen in the figure. So this figure is already here. Fine, then what is this question? The field extends between 0 to 2 centimeter. The electron is detected at the point Q on a screen placed 8 centimeter away from the point S. Where is the point S? Okay, so that is the point S. From that, the distance d between P and Q on the screen is. So we have to find out the distance between P and Q. This problem I think we have already taken in the class. So whatever we did in the class, exactly the same thing we have to do. Do you really want me to discuss it again?
No sir.
Because it's the same problem. I mean, exactly the same problem. The distance there was not from the left end of this magnetic field region. The distance that we have taken is from the right end, and here in that case that distance is going to become equal to 6 centimeter. So I hope you will be able to manage this question. Just go back to that question which we have taken in the class, and you will be able to solve this problem. Okay, here the values are given. In that problem I think the values were not given probably, and we solved it directly by using the notations and not the values. Okay, next question number. Now let's see from question number 9 to 16. Tell me, question number 9,
9
10,
and 14.
11, sir.
9 and 15. 9 and 15. 9 and
9,
15.
15. Okay, let me write it down. Question number 9, 14. Somebody said 14.
14 तो गलती से बोल दिया था सर मैंने.
अच्छा, गलती से बोल दिया, ठीक है. क्वेश्चन नंबर
11, sir.
11. Okay,
Sir, 13.
11, 13. Any other question up to 16? Up to 16 only 9 to 9, 11, 15 and 13 to be discussed. Okay, so let's see what is question number 9. In question number 9, there is a proton beam which is going from north to south and an electron beam is going from south to north. Let us visualize it. This is question number 9 and there is a proton beam. Let's say this positive sign. It is going from north to south. So let's say this direction is north and this direction is south. So this proton beam is going from north to south and there is an electron beam which is going from south to north. So this is an electron beam which is moving in this direction. Neglect the Earth's magnetic field, the electron beam will be deflected in which direction? That is the question. Okay. So first of all, we will talk about, will there be any electric force between them? Yes, there will be electric force between them and the electric force will be attractive. Will there be magnetic force between them? Yes, there will be magnetic force between them, but we know that in comparison to electric force, the magnetic force is going to be negligible. It's going to be very small, in fact. That this problem also we have seen already. So now since the attraction is going to be more than the repulsion, even if I mean, first of all, we can just see whether there will be repulsive force, magnetic force will be repulsive or not. Now because of this positive charge, the current is in which direction? Current is in the downward direction. And because of the negative charge going towards north, the current is again in the south direction. That means the direction of current, because of both of them are same, and we have already seen that when the currents are in the same direction, there will be attraction between them. If the currents are in opposite direction, there will be repulsion. So as far as magnetic force is concerned, there is attraction, and in fact electric force is concerned, that is then also it's an attraction, and therefore this electron will be deflected where? This electron will be deflected in this direction. That means we should say that it is deflected towards the proton. I hope it's clear. Yes or no?
Yes, sir.
Next question, question number 11. Let's see. So this was question number 9. Now question number 11. It says an electron is revolving around a fixed proton in a circular path of radius r. The magnetic field at the center due to electron is. Now how much is the magnetic field at the center? So question number 11, we have already done. Due to revolving charge, how much is the current? Current is equal to charge divided by time period, and time period can be written as 2 pi m divided by sorry, this is not 2 pi r. R is the radius divided by speed. Now once you know the value of current, then magnetic field at the center, we can write it as mu naught upon 2 I divided by radius, which is r, and in the next step it will become mu naught upon 2, and in the value of current I, we can write it as EV divided by 2 pi r into r. Now this is the magnetic field, and here we have to find out what is the speed with which the electron is revolving. And in order to find the speed with which the electron is revolving, what we will do, we will equate the centripetal force, that is when the electron is revolving, there is a force towards center which is electric force, which must be balanced by a centrifugal force mv square by r. So mv square by r is equal to k times, in fact the electrostatic force of attraction, which is 1 upon 4 pi epsilon naught q1 q2. Q1 q2 means there is a fixed proton over here, positive charge. It's going to be q1 q2 divided by r square. Now let's call this equation number 2 and this is equation number 1. So the value of speed, we can put it from equation number 2 to equation number 1. So basically we have to eliminate v, and once we eliminate v, we will be able to find out the value of magnetic field at the center. So I think by doing it, you should get the value of magnetic field as given by option 2. Okay. Now let's do problem number 13 and then 15. So problem number 13, let's see what it is. An alpha particle is moving along a circle of radius r with a constant angular velocity omega. Point A lies in the same plane at a distance 2r from the center. Point A records magnetic field produced by alpha particle if the minimum time interval between two successive times at which A records zero magnetic field is t. The angular speed omega in terms of t is. Okay, so let's try to understand the question first, what it is trying to say. There is an alpha particle which is revolving in a circular path. So this, let's say this is a circular path in which the alpha particle is revolving and its radius is equal to r, and now there is a point which is at a distance 2r from the center in the same plane. So let's say this, from the center 2r distance we have to go. Now this point is point A. Now according to the question, there are two moments when the magnetic field at point A will be zero. Look at this. A records magnetic field produced by alpha particle if the minimum time interval between two successive times at which A records zero magnetic field is t. Then we have to the angular speed omega we have to find. So when magnetic field at this point A will be zero. Okay, so magnetic field at this point will be zero when the position vector and velocity vector are making just hang on. Some issue with, okay, two minutes, just hold on. I don't know what's happening, I'm unable to see. Okay, so now let's see, just draw a tangent over here. So we are drawing a tangent over here. Why we are interested into tangent, I'll explain you in a while. So these are the two tangents. Now what will happen when the alpha particle is moving in this direction? Then at this moment magnetic field at A will be zero, and when the alpha particle is here and moving in this direction, then again the magnetic field is going to be zero, because in these two positions you can see the point A lies along the line of motion of the alpha particle. And according to the
Sir?
question, yes, tell me.
We can't see the changes on your screen. It's stuck.
Okay, so you are unable to see, I'm writing on. Is it for everyone? You are unable to see?
Yes, sir. Your screen is stuck.
Yes, sir.
What happened?
The screen is stuck at one place.
Screen is stuck. Okay, I don't know today what's going on. Let me reshare it. So I hope now the tangents are visible to you.
Yes.
sir.
Okay, fine then. So now look at these two moments. At these two moments, the magnetic field at point A will be zero, because the point A is along the line of motion of the alpha particle. Now what the question says, if the minimum time interval between two successive times is t, that means if I say that this is t equal to 0, then this must be t equal to t, and this is the motion of the alpha particle between 0 to t. Okay, so now we have to find out what we have to find out, how much is the omega, and let's see how do we do it. We will first draw this line. This is perpendicular, and here also we will draw, this is perpendicular, and we want to find out how much is this angle and how much is this angle. For that we have certain information. Let's call this point as O, that is A, this point is B, let's say this point is C, Now, if you look at the triangle AOB, the distance AO is twice of R. This distance is R. So, we can say that for this angle, if I call this angle as theta, this is also theta. Base is R and hypotenuse is 2R. So, we can say that cos theta is equal to 1 by 2. Theta is equal to 60 degree or pi by 3 we can say. So the total angle 2 theta is going to become 2 pi by 3, and this is the angular displacement. In fact, angular displacement is equal to angular velocity into time, which is 2 pi by 3, and from here t we can find it out as 2 pi by, no, we have to find omega and not t. So omega from here comes out to be 2 pi by 3 times t. Let's see. Yes, option 2 is correct. Okay. So I hope this question number 13 is clear to everyone. Now let's do question number 15. What is it?
Sir, could you explain 14 also?
14 also. A particle is moving with velocity I cap plus 3j cap and it produces an electric field at a point E vector equal to 2k cap. It produces magnetic field at that point equal to. Well, this question is there in the sheet, probably in exercise 2. If velocity is given to us, electric field is given to us, then how to find magnetic field basically. Okay, so if you look at the expression of electric field and magnetic field, then let's see question number 14. So let's say that this is a particle, and forget about the particle. What is the expression for electric field? Electric field at any point, it is 1 upon 4 pi epsilon naught charge divided by r cube times r vector. I mean, this is a formula for electric field. And what is the formula for magnetic field? Because of a moving charge particle, it's mu naught upon 4 pi q v vector cross r vector divided by, can anyone help me here? It is what? Q times v cross r divided by
R cube, sir.
r cube. Now this is electric field and magnetic field. We want to figure out a relation between electric field and magnetic field. That, let's say, if you know what is electric field, can you find out what is magnetic field? Because this question demands us that only. We know velocity vector, we know electric field vector. So can we find out what is electric field? I mean, if you look at the magnitudes, I think we can compare the magnitudes. What is the relation between their magnitudes? If you do E by B, then what you are going to get? You divide the two, then you are going to get 1 upon epsilon naught mu naught, and r cube q will get cancelled. And in fact, we're just comparing the magnitudes. So here it is going to be v sine theta, isn't it? Because if you write the magnitude of b, it will be vr sine theta. And for when you just divide the magnitude, this is what you will get. And now we want to find out if there is any specific relation between E and B that we can find. Now what is this 1 upon mu naught epsilon naught? This can be written as c square v sine theta E divided by B. Now is there any specific relation that we can bring in between E and B? From here that we have to see. So what we can do, E is equal to c square B into V into sine theta. So maybe we are close to getting some relation between them, and that we can write that. First of all, let us just see if we have made any mistake. No mistake so far. QQR. Okay, fine. So till here there is no mistake that we have done here. Now E is equal to c square BV sine theta. Then we just have to think, maybe we can write E vector is equal to c square times either V cross B we have to do, or B cross V we have to do. And the correct relation will be B cross V. It will be B vector cross V vector. Then how it is, you can just check it on your own. Let's say there is a charged particle which is in this direction moving plus q, and let's say
Sir,
that
the
this,
result you are getting, you can only get it if we are doing B by E, not E by B. We should be getting B is equal to C square times.
are you sure that B by E?
Yes sir, I am sure क्योंकि मैंने किया है ये एग्जाम में.
नहीं तो B by E अगर हम करते हैं तो म्यू नॉट विल बी इन द न्यूमरेटर, isn't it? If you do B
Sir,
by E,
B.
check it, isn't it? We are doing E by B, so we are getting 1 upon mu naught epsilon naught, right? And what is 1 upon
So,
mu naught epsilon naught? I think yes, V sine theta will not be in the numerator. That is our mistake. This V sine theta will be in the denominator. Yes. Okay, so this V sine theta will be in the denominator here also. It is V sine theta, and we are going to just yes, that is a mistake here. So now what we will get from here, we get B is equal to E times V sine theta divided by C square. Now the question is whether it will be E cross V or V cross E. Then it is going to be V vector cross E vector. How? We can check it with this example. At this particular point, what is the direction of electric field? It is in this direction. This is electric field. Now what is the direction of magnetic field? Direction of magnetic field is out of the plane of the paper. Now you see whether V cross E should give you B or E cross V should give you B. That is what you have to see. Definitely V cross E is giving us B, and therefore V cross E is the correct expression. So now what we can do, we can actually remember this expression, I mean next time, so that we don't have to do it again. So how is magnetic field? It is velocity vector cross E vector divided by C square, and in this question V vector is given, E vector is given. We can find out how much is B vector from there. Okay, so I hope this question number 14 is clear. Let's now get into question number 15. Two observers moving with different velocities see that a point charge producing same magnetic field at the same point. Fine. So their relative velocity must be parallel to r vector, where r vector is the position vector of the point A with respect to the point charge. All right. So now the two observers moving with different velocities see that the point charges produces same magnetic field at the same point. Let's try to understand this question number 15, what it says. So question number 15, it says that magnetic field, what is the formula for magnetic field? Mu naught upon 4 pi V vector Q times V vector cross R vector by R cube. Now for both the observers, they are moving with different velocities. Fine. In this, for both this quantity, position vector for both of them, it is same. The two observers moving with different velocities see that the relative velocity must be parallel to r vector, where r vector is a position vector of the point A with respect to the point charge. Okay. So the two observers, they are moving with different velocities. They see that a point charge produces same magnetic field. It means that this quantity is same for both of them. Okay. And what else is same for both of them? The relative velocity must be parallel to r vector. And what is this r vector? It is the position vector of the point A with respect to position vector of point A with respect to the point charge. Point A, where is the point A? There are observers only, right? Okay, fine. So let's say that this is a point charge Q, and this is the point, and the position vector of this point is this. Okay, now there are two observers. The relative velocity must be parallel to r vector, where r vector is a position vector. This, they are saying that the relative velocity must be parallel to this r vector. Okay, whether this statement is true or not, we have to figure out. Let's see how do we do it over here. So the question is that when we apply this formula for an observer A and for an observer B who are moving with different velocities, Since these two observers are moving with different velocities, when we apply the formula for both of them, LHS comes out to be same for both of them. Mu naught upon 4 pi q is also same for both of them. And when we apply the formula, in this formula, what is r vector? R vector is the position vector of the point with respect to the charge. So A will observe R vector and B will observe R vector to be same. I mean, this R vector will not be different for A, it will not be different for B. What will be different? Velocities may be different. However, in this situation, the velocity will also not be different. That means the velocity of the point charge Q relative to A must be equal to velocity of the point charge Q with respect to B. This is what we can conclude from here. Since the relative velocities of the 2 point charges are same for observer A and B, therefore the magnetic field at this point is same. Now from here we can write it as that VQ vector minus VA vector is equal to VQ vector minus VB vector. And from here what we are able to observe here, that VA vector is equal to VB vector we are getting. No, but this cannot be true actually. Let us just relook at the question and its language. There are two observers moving with different velocities. See that a point charge produces same magnetic field at the same point. Okay. All right. Where r vector is the position vector of a point A with respect to point charge. This statement is all right. Then the relative velocity must be parallel to r vector. Now look at it. The only possibility that we get here is that VA is equal to VB from this conclusion. Now, according to the question, the velocities are unequal. Okay, so if the velocities are unequal, it means now the only possibility that we have is that magnetic field must be zero. We have no other possibilities actually. Again, I'm repeating this question. Let's see it again. When we apply this formula, in this formula, what is B vector? Is a magnetic field. V vector is the velocity of the charged particle with respect to the observer. So the question says like this: magnetic field B for observer A is same as magnetic field B for observer B. Okay. Now next step, mu naught upon 4 pi. We are applying the formula for observer A. This velocity of A relative to velocity of the point charge in the formula, what is this V vector? This is velocity of the point charge relative to the observer. Cross product R vector divided by R cube, and this is equal to mu naught upon 4 pi q times velocity of the point charge relative to observer B cross R vector divided by R cube. Okay, and in the next step what we will get, VQA vector equal to VQB vector, and in the next step what we get, VA vector equal to VB vector. This is what we are getting. We are saying that the velocity of the two observers must be same, but in the question they are saying that it is not same. What does it mean? It means that the only possibility now we have is that it is 0 and this is also 0. And if the velocities are different, then the only possibility when the two terms LHS and RHS can be equal is when the cross product itself is 0. Okay, so now the possibility that we have, when it can be 0, it can be 0 when VQA vector cross R vector, it's making it, they are parallel, both the vectors are parallel, and VQB vector cross R vector, they are also parallel to each other. Now if both are parallel to each other, what does it mean? That the velocity of charged particle with respect to A is parallel to R vector, and this is also parallel to R vector. That is the only possibility. If the magnetic field is non-zero, then it is not possible. Non-zero magnetic field is not possible. The magnetic field must be zero is the only solution to this. I don't know whether you got it or not, but just go through this problem once again. It's a conceptual problem. If you don't get it during the offline class, I'll make it clear to you. Next question number
Sir,
16.
what I thought was कि जो है R वेक्टर जो है
हाँ
अगर मतलब अब जो हमारा चार्ज क्यू है
हाँ
अगर वो विथ आर वेक्टर मूव होगा
हाँ
तो V क्रॉस आर तो हमारा जीरो आ जाएगा तो मैग्नेटिक फील्ड
वही मैं कह
पता
रहा हूँ
नहीं
कि अगर मैग्नेटिक फील्ड नॉन जीरो है और इक्वल है, then the
वही
velocities
मतलब
of A and B must be same. और वो दे नहीं रखा है. Velocities of A and B are different according to the question. Then the only possibility that we have is that the magnetic fields are zero for both of them.
अच्छा यानी they don't if they are perpendicular to each other then there will exist a magnetic field अगर velocity of charge q and r vector perpendicular एक दूसरे को तो
नहीं, velocity को छोड़ दो. देखो, question says the magnetic field are same for both the observer, right?
yes sir
Same means what? Means 2 equal to 2 or 3 equal to 3, but 3 or
हाँ
0 equal to 0 is also one possibility. So
yes
अगर
sir
मैग्नेटिक फील्ड इक्वल है और नॉन जीरो है, then this is the conclusion, the two observers must have same velocity, right?
अच्छा
But as per
yes
the
sir हाँ
question, the velocities are not same. It means the now the only possibility is that the magnetic fields are same and they are zero. Okay,
okay
so if the magnetic fields are same and they are zero, then these two vectors must be parallel to each other. These two vectors must be parallel to each other, which means that the velocity of the charged particle for both the observer is parallel to r vector. The only possibility that we have is this. I hope now it is clear. Okay, now
yes
we
sir
will do from 16 was not there, right? Okay, it was not there. Now 17 to 23. Question number 17 to question number 23.
no question
Anyone? 17 to 23. You can also write down
Sir, 21.
20 and 21 or only
No,
21?
only 21.
Only 21. Okay. So let's see what is question number 21. PQ is a region of uniform inward magnetic field. Fine. So this is the region of magnetic field. A particle Q enters, mass M enters the region at an angle theta with a speed v at time t equal to 0. The displacement of the particle in the region of the field. Displacement we have to find. You know what is displacement? Displacement is the distance between the 2 points where it enters and exit. That means this point and this point. You have to find the distance between the 2 points. That means if you imagine a circle, because this is going to be a circular path, and you just have to find out the chord length actually. So what will be this chord length? Okay, so it enters and then it exits. So according to the question, we have to just find out the chord length.
Okay. Yeah,
I
got
hope
it, sir.
now
I
you will
thought
be
it
able to
was
do.
the distance and I was getting the wrong answer.
Okay, not distance part, so we did it in the class,
Yeah,
right? So this angle is theta and then you can do the geometry.
yeah.
This is 90 minus theta, this is theta and this is theta, and the chord length can be found. Okay,
Okay.
next, any other question?
so 26th देखिए एक बार
26th question. Let's see. A singly ionized magnesium atom ion is accelerated to kinetic energy 5 kilo electron volt and is projected perpendicularly in the magnetic field, the radius of the path formed. Now we have
इसका
a
आंसर 48 आ रहा है सर मुझे पता नहीं 10 गिवन है 10 आ कैसे सकते
so
हैं
formula जो हम use करेंगे, that will be under root of 2m q into v divided by qb. Now the mass of the
सर
magnesium
काइनेटिक
atom
एनर्जी के टर्म्स में पूछा है ना
एक्सेलरेटेड टू काइनेटिक एनर्जी, ऐसा कर लो, चलो इसको के ई काइनेटिक
हाँ
एनर्जी. Now, what is the value of mass that you put over here?
48.
The singly ionized magnesium atom, 48. So 48 क्या? 48 kilograms. 48.
So it should be
Kilogram.
24 itself, no?
Why would it be 24?
Magnesium, no?
Atomic
12
number is
is
given.
the
Atomic
atomic
number
number.
is given as 24.
अच्छा,
No, that
मैग्नीशियम
is not
एटम
the
है,
atomic
एटम
number.
है सर, एटम है, एटम.
एटम का कितना होता है मास? एटॉमिक मास बताओ. आई थिंक 24 ही होता है. 24. Yes,
24 ही
24
होगा
only.
सर.
24,
24
but
ही
we don't
होगा,
have to put
इसलिए
it
गलत हो
24
गया सर.
kg. It's 1.67 into 10 to the
हाँ,
power
वो पार्ट
minus
तो सही है सर.
27 kg. This is what we have to put there. And the charge will be
नहीं, ठीक है
1.6
सर, ये
into
तो
10 to the power minus 19. And then kinetic energy, again we have to put it. I mean, little bit calculation is going to be
हाँ,
there.
अब हो जाएगा सर.
5 electron volt,
नहीं,
1.6.
एटम तो देखा ही नहीं मैंने, 48 डाल दिया मैंने मास
हाँ,
का.
ठीक है. ये तो याद भी रहनी चाहिए तुमको. Okay, anyways, next question.
Sir, 23.
23. A particle with a mass m and charge q moving with a velocity v enters a region of uniform magnetic field as shown in the figure. The particle strikes the wall at a distance d from the entrance slit. If the particle's velocity stays the same, velocity stays the same, it's the speed that stays the same, okay? But its charge to mass ratio is doubled. Acha, that means the velocity with which it enters, it remains the same, but you double the charge to mass ratio, the distance from the entrance slit. So we have a formula in question number 23 of radius. Radius of the circular path is mv divided by qb. So it is equal to v upon q by m times b. So what we are changing here is the charge to mass ratio. This is also called a specific charge, and this specific charge you are making it double, right? So we can say r is inversely proportional to q by m. If you make it double, radius will become half. If radius becomes half, diameter becomes half. So earlier if it was d, now it will be d by 2, isn't it?
Got it.
So that means n is equal to 2. Okay, any other question?
नहीं सर.
Well, the time is also up, so fine then. If there is any question apart from this, we can discuss it during the offline class tomorrow. Okay, fine then.
फिर कल से EMI स्टार्ट हो जाएगा कि EMF ही करने वाले हैं?
नहीं, वो अर्थ मैग्नेटिज्म थोड़ा सा बचा रहेगा.
अच्छा, ठीक है.
तुम्हारी क्लास में तो आई थिंक फिर भी हो जाएगा. आई थिंक इन JP2 इट्स लिटिल बिट लैगिंग. ओके, फाइन देन.
ठीक है सर.